Hello, friends, welcome. Friends, yesterday Mr. Gopal Vittal spoke in his earnings call for Q1 FY25. So, this earning call is pretty important because it gives us an opportunity to understand from the CEO himself what kind of business challenges that he is facing and what strategy that he is going to adopt to overcome those challenges. So when I was listening to this call, I thought that I will be able to add certain value, and that is the whole purpose of this discussion. So what I have done, friends, is that I have picked up certain issues and have broken those issues in some questions which I am going to lay before you, and we are going to go through those questions which are extremely important from the point of view of both Airtel as well as for the consumer to understand, right? Because for Airtel it is important because it will be able to drive more revenues and more value for their stockholders, and the consumer will be able to get better quality services. Now, if you look at the Airtel business is broken into two compartments. Apart from Africa and other things, we just forget about that. There are two main components of their businesses which is driving huge value. First is the mobile business, which is wireless, right? Another is the home business, which is mainly anchored over broadband services, right? And then there are enterprise business also, which is also the broadband is a major component of it. Now, if you look at Airtel's KPIs, you will be able to understand why the home business and the enterprise business, which is primarily anchored on broadband, is important. And that we will be able to see through the data which is released in their KPI report. So if you look at this, you will find that the average revenue user for wireless, if you look at the mobile user average revenue, which is 211 rupees per month, whereas the home segment, the revenue is 572 rupees per month. Now, even though the wireline customer base of Airtel is quite low compared to the wireless customer base, this acts as a huge driver to elevate their weighted blended ARPU. So let me just give you a calculation before you so that you will understand that why this is so important and why Airtel is going to be focused in grabbing as much enterprise and home broadband user subscribers as possible. So let's assume that Airtel has got 350 million mobile wireless subscribers. They have more, but I'm just making it up just to prove a point. So 350 into 220. Why 220? Because Airtel recently made an announcement of tariff increase. So I'm assuming that the current 211 will definitely go to 220. And then we have Airtel has got around 9 million broadband subscribers. So I'm just basically saying, okay, 10 million, 10 into 550 rupees. And now if I divide this by 360, that will give me a blended ARPU. So if I divide this by 360, so we get a blended ARPU of 230 rupees. So you can imagine that just 10 million subscribers will be able to drive their blended ARPU by 230 rupees from 220 rupees, right? So 10 rupees, ARPU, the blended ARPU increased by just 10 million subscribers. Now, Mr. Gopal Vittal said that there is a huge opportunity of around 25 to 30 million high value customers who currently do not have broadband connection. So if I increase this to 25 million, 10 million if I increase to 25 million, which is a realistic number, this ARPU now goes to 252 rupees. That is why it is important this mobile broadband, the fixed line broadband driven by both fiber as well as FWA is very, very important for Airtel. Right, so this answered this particular question. So I have laid out this question. The second question is answered by this explanation. Right, now the next question, which is very, very critical. This is simple. This is basically from a business strategy anybody can answer. Now this question is laid out as the first question, which says that why Airtel made an announcement of standalone 5G for their fixed wireless services, because they could have very well used the non-standalone 5G also NSA network, right, for their FWA. Why for fixed wireless standalone 5G is crucial. Now Mr. Vittal gave an explanation. So what I am going to do, I am going to further elevate the discussion to a higher level and make it more simple for other people to appreciate than what Mr. Gopal Vittal described in his earning call, right? So what he said was, he said that in a typical FWA scenario, let me just take my face out. So this is a typical FWA scenario. So let's look at this first. Let me just take this here. You will find that what is FWA? FWA, there is an antenna on the top of the house, right? Where there's a cable coming, and then we have a router here which will drive Wi-Fi, and then we have computers here, right? So this FWA is talking to the base station, right? Using a spectrum band, correct? That is what it is. So there is an uplink and there is a downlink. This is a typical situation. Now, in an NSA mode, what happens, let's say in a non-standalone mode, whoever understands this, and let me just tell this clearly so that people who do not have a clear understanding of NSA, the first principle in an NSA mode, non-standalone 5G mode, that you need an anchor 4G spectrum, which is crucial. You need an anchor 4G spectrum. Without an anchor 4G spectrum, your non-standalone 5G is not going to work, because that anchor 4G is crucial. Okay, so let's say that there is an 1800 megahertz spectrum, which is an anchor 4G spectrum, which the FWA is using to work in a non-standalone mode. Now, in order to increase capacity, you need to lay out the 3500 megahertz band on top of the 1800 megahertz band, so that the capacity of the overall network can be enhanced. Now, Mr. Vittal did mention that 3500 is basically being used as a downlink, and the 1800 megahertz band is used as an uplink. Now, if you look at the overall spectrum width of 3500 megahertz band, this is 100 megahertz, right? Though I have converted this into 50 megahertz just to align with the 1800 megahertz FDD spectrum, because FDD is 2 into 1800, right? So you have got 100 megahertz of downlink, plus let's say 1800 megahertz, 10 megahertz of downlink, so 110 megahertz downlink. But because you are using the 1800 megahertz 4G as an anchor, the 1800 megahertz 4G uplink is only 10 megahertz. So your uplink is going to be very thin, your downlink is going to be very fat. Therefore, this connection, the 5G FWA in the NSA mode, is going to be highly asymmetric. It is not going to be symmetric. Now, that kind of network, broadband connection, we don't need today. We are more in a symmetric mode today. The uplink and the downlink has to be symmetric, because all kinds of applications that we are doing, like you are uploading videos, we are doing a lot of other stuff, we need symmetric bandwidth for broadband connection, which is possible in case of 5G, in case of fiber optic. But in case of non-NSA, in not SA, a non-standalone network, you understood that the network will become very thin on the uplink direction. So what he is doing, he is saying that he is going to deploy an SA network in order to increase the uplink speed of the 5G FWA network. That's what he said. That's what he meant in the call. Now, what I'm going to do is I'm going to explain to you technically how the uplink part of the 5G network is going to be much more thicker compared to an NSA network if you are going to use SA network, right? So let's say if you are going to use an SA network, then what will happen? You are no longer required to lock in the 1800 megahertz, any of the 4G carrier down below, which are thinner compared to the 3500 megahertz band. So you will lock in the 3500 megahertz band. So you will get what? You will get a 100 megahertz spectrum, right? To lock in. Now, both your uplink and downlink is going to happen now only in 3500 megahertz band. You don't require the underlay 4G network. So how it is going to raise the thickness of the uplink part of the network? What you can do is that you can configure this TDD network in such a way that downlink, let's say, is 2 times, and the uplink is going to use the resources only 1 time. Or you can use 1:1 also, depending upon what configuration you use. Means whatever capacity that you have in this band, which is 100 megahertz, you can break this into 2 compartments, 50% for downlink and 50% for uplink. Typically, we don't do that. We use a 2:1 or maybe 3:1 or something else, right? But it is definitely going to be fatter compared to using only 1800 megahertz band. Let's say if you have got 100 megahertz band and if you are using 2:1 1, then you divide it by 3, so you get a 30 megahertz of uplink, 33 megahertz of uplink, and around 66 megahertz of downlink, right? So your uplink is, so that exactly what he meant. Now let me make one more point here. The point here is that how is this downlink capacity getting increased in case of 5G? This is a question we have to understand. It could be LTE also. Why in case of 5G the downlink capacity gets increased much more, means the efficiency of 5G band is higher compared to 4G band. Why it is that? That's how you will be able to leverage this capacity much more compared to if it was a 4G network. The answer lies with path diversity. What is path diversity? In a typical 5G base station, what you do is that you deploy multiple antennas, and those antennas is able to create multiple beams. And these multiple beams, what they will do? They will actually able to serve different FWAs. So every beam will be separate in path. So since the beam is going to be separate in path, what will happen is that the capacity of the spectrum will become multiple times the number of beams that you are able to create from the base station. So instead of having one single beam where multiple users are tapping into, you can have one single beam for one user. It is just simplistic. It's not like that. You can have one beam will be shared by multiple users, but you will have multiple beams possible in case of 5G because of what you can basically do beam steering or beam diversity using antennas. Now for that you need multiple antennas to be packed in a small space, because your base station will become very unwieldy, and the antenna sizes depends upon wavelength. So if you are in 3.5 gigahertz band, you will be able to do it in a reasonable manner. But higher the frequency, higher the beam steering capability becomes, and you are able to do path diversity also increases proportionately high. So let's say if you are using 26 gigahertz band, then your antenna is going to be smaller and your beams are going to be much more sharper, and there will be multiple number of beams which you will be able to drive. So this is a typical capability of 5G network, and that's why 5G is able to drive larger speeds. Now this beam steering or the beam splitting capability is very easily possible in the base station, because base stations are configured much larger antenna sizes and more number of antennas can be packed. Whereas in case of FWA, these capabilities may not be there as significant what it is possible in the base station. So your uplink will be limited even when you are going to use an SA network, right? It may not be equal to the fiber capability because of this limitation of uplink beam steering in case of 5G network compared to what it is possible in the downlink. And that is the reason why Mr. Gopal Vittal mentioned that he is going to make a transition to this 5G SA network is for FWA is going to be a temporary solution. He said that it is a temporary solution and is ultimately going to transition to fiber. That is why he made that statement, because uplink cannot be compared with fiber even if you are going to deploy any kind of network. Even if you are going to deploy a 5G 5G FWA in a standalone manner, you won't be able to compare in a fiber condition where both uplink as well as downlinks are symmetric, because there is no such problem or kind of bottlenecks that I just described in case of a typical 5G network, where the antenna capabilities in the device side is quite limited compared to what you have in the side of the BTS, right? So that is the answer to this question, why it is a temporary solution. Now the next answer is, what is Airtel's standalone strategy for 5G mobile network? So for that we have to go and look at this particular block of spectrum. Now let's look at this block of spectrum. What did Mr. Vittal say? Mr. Vittal said that Airtel has probably the largest quantum of mid-band spectrum. He is right. So if you look at, Airtel has got 2300 megahertz spectrum, 2100 megahertz spectrum, 1800 megahertz spectrum in large quantum, which Reliance does not have. Neither Vodafone Idea has. They have the largest quantum of mid-band spectrum. So what his plan would be SA network for mobile would be to make a transition of, let me just go to this chart, that will be useful to understand. What he will probably do is he will convert one of the spectrum band or multiple of them to 5G. He will convert, let's say he starts with converting the 1800 megahertz band to 5G. So he'll reform 4G from here and he'll convert this into 5G, right? Then going forward, he'll convert the 2100 megahertz to 5G and 2300 megahertz to 5G. And the 800, 900 megahertz is pretty thin, it will make no sense, right? But mostly the mid-band spectrum is an opportunity that will convert. So what will happen? He will have the 3500 megahertz of network as 5G already he has. So let's say that he starts with the 1800 megahertz band, he converts into 5G. Let's assume that. So what will happen when you deploy a 5G network, right? Standalone network for mobile. So what you have now? You have a network already, a spectrum band which is already 5G, which is 3500 megahertz band, and then the 1800 which is currently 4G, you convert that into 5G. So this is now an SA network, standalone network with two frequency band, 3500 and 1800. So now there is no more compulsion to latch into a 4G network. This mobile phone will now be able to latch directly into a 5G network. So this will be 1800 megahertz band. And it will be able to use carrier aggregation also, he mentioned that. So now you have a situation of 3500 and 1800. Let's assume that this is 10 megahertz of 1800, both running together, right? So you are able to see these two block of spectrum as one single block of spectrum, right? If you are going to use SA and use carrier aggregation. This is what he mentioned in that call. Now what is going to happen? Let's say if you have a mobile and this mobile is locked onto the 1800 megahertz band, because that is the spectrum he will get at the edge of the network. Let's say if you have a base station and this is the network coverage you have, your 3500 coverage is going to be limited. So your edge of the network, you will get only 1800 megahertz band. So when you are locked into the 1800 megahertz band at the edge of the network, what will happen? Your uplink as well as downlink will be in the 1800 megahertz band even when you have got carrier aggregation. So in order to get a better coverage of 3500 megahertz band, your BTS density has to be, tower density has to be much higher. But 1800 megahertz band, the coverage can be obtained at the edge of the network. So if you are locked in the 1800 megahertz band and you don't get the 3500 megahertz band, then your both uplink and downlink is going to be pretty thin, because only 10 megahertz of spectrum that you are going to get. And in the 1800 megahertz band, you will not be able to do any kind of beam splitting or beam steering, because this frequency band is so low that neither the base station nor the handset will be able to do beam steering and beam splitting to able to do path diversity to increase spectrum capacity. So your spectrum capacity is going to be limited by only 10 or 15 megahertz, how much you convert. But if you are near to the base station, then you will be able to lock into these two base stations, two spectrum bands together, and you will be able to create a larger capacity and you will get better speeds. So the mobiles, their quality of experience in case of an SA 5G network in this configuration of 35 as well as 1800 megahertz, both converted into 5G, mid-band spectrum plus high-band spectrum, is going to work if the mobile is nearer to the base station, not at the edge of the base station. And inside the homes, it will not work, because the penetration of 1800 inside the home is pretty poor. You got it? So his 5G SS strategy on mobile using mid-band spectrum is not going to work in the manner in which he described. That is the reason, if you look at this particular chart, I mentioned that why Airtel will need low frequency band spectrum desperately. Though he said that he doesn't require low frequency band, I think that this is not the right strategy to go forward. He is not going to be able to do good enough 5G standalone on mobile because of the reason I explained, because 3500 megahertz will not have good amount of coverage. Even if you are going to be locked into the 1800 megahertz band, then you are going to be limited by the capacity of the 1800 megahertz spectrum band only. In case if you are able to reform large number of spectrum band, your device is going to become more complex. For example, let's say if you reform the 2100 megahertz spectrum band also for 5G, let's assume that you do that. You reform 1800 megahertz, then you reform 2100, then you require do 2300, then you do 10. Imagine the kind of complexity the device. So you have to do carrier aggregation across these all four bands. All four bands have to be carrier aggregated. Now, if you are going to basically do carrier aggregation across all five bands, which is going to be impossible, by the way, to do, then you will have how much spectrum? In 900, if you see in a pan-India average, this is 8.48 megahertz. So let's say if you are inside the house, as Gopal Vittal said, that the low frequency band is only for coverage. It is not for capacity. He said that, right, in the call. So inside the house, with this such a thin, slice of spectrum, what is going to be your 5G speed? It's going to be zero, virtually nothing, right? It's going to be completely useless. And you will not get neither 1800, not 2100, not 2300. As soon as you come out of the house, you will get 1800 maybe at the edge of the network. You maybe get 2100. So you will be able to combine 1800 and 2100. But you may not get 2300 or 3500, right? Depending upon the tower density you may get, you may not get. But if you have a very good quality handset with higher CA capability and near the base station, you will get everything. So the bottom line which I am trying to say is that for 5G SA strategy on mobile, right? Your SA strategy for mobile is going to work only if you are close to the base station or in a location where the coverage of all the bands are in good quality, which is not the case inside the house, right? So your 5G SA for mobile is not going to give you neither speed nor quality. Speed you are able to will be able to get only near the base station or in a location where the coverage of especially the high frequency capacity band is good. Now there is a problem here. The point here is that why would you even do SA for mobile? Let's answer this question. Why you want to do SA for mobile? To do what? Just for the sake of it, it does not matter at all, right? SA for 5G FWA we understood why you did 5G for FWA, right? But there is one more point for 5G for FWA before we start getting into deep dive into 5G for SA for 5G for mobile is that when you do 5G for FWA, apart from getting the advantage of uplink, which I described right now, you also do one more thing. You are able to do network slicing, and therefore your broadband speeds are going to have a better SLA. Because what we will be able to do, so let's say this is the pipe. In case of 5G FWA, you will be able to slice this pipe into two different compartments, one for best effort, one for your broadband network, although content and OTT, which is possible only in SA network. In case of a non-standalone network, this is not possible. So your quality of service inside the house is going to become better in case of SA. Now the same strategy should be working in case of mobile also, because if you are going to use 5G only for speed, which we have seen today, it doesn't serve any purpose. 5G for speed is completely useless. There are no applications in the mobile which is able to leverage the 200, 300 or 500 MB speed that we are getting on mobile. It's completely useless. So all the futuristic application for 5G, today 5G may not have been possible to monetize, but tomorrow, let's say there are applications which are sitting here, apps which are sitting here, which requires SLAs. SLA means dedicated connection with the network, right? Which is on top of the best effort network. So there is a best effort network, we need a dedicated connection for the sake of security or for sake of constant perpetual quality, right? So for that you need these mobiles to be able to do network slicing on an application level. Now if you are standing near the base station, if you are able to do network slicing, what is the purpose it will serve? Because most of the time you are sitting in your house or in your office, right? So if the mobile does not work inside your house and you are not able to get an adequate capacity inside your house, so that you will be able to drive all these 5G SA features, which are network slicing at the handset level, at the application level, then 5G will never be able to get monetized, because 5G is not about speed. It is about these network slicing application network slicing capability at the application level and low latencies, which will be able to restrict the transmission within the operator's network, and it gives a lot of security from the point of view of driving various kind of applications like banking application. Now, with such a thin network that you have at the low frequency band, what Gopal Vittal has said is probably right, because this 800 and 900 megahertz with just 8.48 megahertz of spectrum, there is absolutely no possibility of driving any meaningful capacity even within the house. And that's why this network, this low frequency network, has to be at least 20 to 25 megahertz. 5G services at the mobile handset level with SA network is completely useless if you do not have sufficient capacity in the low frequency band. As Gopal Vittal has said, that low frequency band is for coverage, but I would say that low frequency band should also be able to be equipped with adequate capacity, not very high speed, and because high speed is useless. What I'm going to do with those applications today? We have already seen, we are getting 300 Mbps, 400 Mbps on the mobile. What we are doing with that? Nothing, right? FWA we can understand. But for mobile, you need adequate capacity so as to be able to leverage those 5G applications. So when Airtel says that it does not need low frequency band, I completely disagree with them, because 5G is not about high speed broadband. 5G is about those network slicing application which may become popular in near future. If you don't have the capability, how will you deploy those applications? Because today you don't see any application because the network doesn't have the capability. Tomorrow the network will have the capability, then only those applications will come now. So if you do not have 20-25 megahertz of spectrum in the low frequency band, which other countries have, China Mobile has, in US, service provider has 30 megahertz of spectrum in the low frequency band, then only you will be able to drive all these features inside the house, because the Wi-Fi is not going to work. Wi-Fi will not carry those 5G network slicing application inside the house. Okay, so that answers my last question, why Airtel needs low frequency band for effective SA deployment for their 5G mobile networks at the handset level. Do you understand now what the issues are, right? And why it is important for Airtel to make sure that they have adequate low frequency capacity, and why it is important for the government to focus on low frequency band strategy more than anything else. Whether it is 6G, whether it is 5G, 7G, 8G, 9G, 10G or any G, nothing will get deployed in the country unless you have a effective low frequency band strategy for our country. And nobody is focusing on that. The operators are not telling the right story because of their own commercial interest, and I don't blame them. It is the government which is responsible. They have screwed up the low frequency band completely. So what the operators will do? They will definitely, for enhancing their stockholder value, will have to say that we don't need low frequency band. If you are going to sell low frequency band in platinum and gold prices, the operators will say we don't need it, right? So it is the government responsibility to have an adequate strategy for low frequency band. If they really want 6G, so forget about 5G, even 6G is not going to work, even 7G is not going to work, 8G is not going to work, because you can't change the basic physics. The physics will remain the same. The coverage is not going to penetrate indoor. Nothing is going to happen, and therefore you will never be able to use your any kind of technology at the mobile level, because there is no signal entering the house. What is going to happen? Okay. So, friends, I think you probably understood this, why it is important for low frequency band, and what is the reason for Gopal Vittal stating certain strategies for their network deployment, and I have tried to explain those things technically as much as was possible for me in this video in a small amount of time. And if you have any question, you let it out in the comment section. I'll try to answer them as much as I can. Thank you very much for your time. I'll come back to you next video next time.